Hi everybody, welcome to another IZ8 TWF arcade repair video. This is a clone of the game Ripoff, originally made by Cinematronics. This PCB was made by the Italian company Microhard. This board is missing almost all TTL proms. The RAM ICs are also missing. This jumper block was also removed. And another jumper block is missing here. So this repair started by ordering the missing parts. The RAM ICs are the old 2101 and the missing proms were of two different sizes. With these NOS parts I can start repopulating the PCB. Of course, the RAMs can be simply put back in their sockets. But the TTL proms need first to be programmed with the right code. Luckily, all the old Cinematronics black and white vector games share the same proms, so it's easy to obtain the correct dumps. And once programmed, also the proms can be put back in their sockets. And last, the jumper blocks have been populated. These jumpers allow to interrupt various signal paths, and this may help to identify failed ICs. To test the board, I've used the previously repaired Sky5 monitor and the attract mode looks fine. This is the vector monitor PCB and it's identical to the one I've already repaired for the Tail Gunner clone. Links to the previous videos as always are in the description. As you may know if you watched my other videos, the digital to analog conversion is done on the monitor PCB. As always, I start by testing all electrolytics ESR. And this one looks really dead. Indeed, the LCR meter confirms that it's dead. By the way, the old versions of the Cinematronics monitors have this rather odd primary oscillator circuit with a resistor that runs so hot that it cooks the PCB material under it. The failed capacitor was in this oscillator circuit and no other bad capacitors have been identified. The next step is checking all the diode and transistor junctions with a multimeter. And this transistor looks dead. The multimeter never shows a proper PN junction drop voltage that should be about 0.7 volts. So I desoldered the suspect transistor. And indeed, it is just dead. Both failed parts so far are in the primary oscillator driver circuit, so I want to check also the transformer in this case. Luckily, I've written down all the winding inductances measured on the other working monitor. And so far all taps look good. And also the high voltage secondary looks okay. So I just replaced the capacitor and the transistor that failed. Before powering on, I'll check the correct orientation of the video connector. Since all the ones I've got can be inserted in both ways, I'm going to check the connection for one DAC bit. If I have continuity, then the cable is inserted in the correct orientation. And no, it's inserted in the wrong way. Now it's okay. So it's time to power on the monitor. I'm going to first check the voltage rails that power the primary oscillator. That was the circuit with the failed transistor and capacitor. So let's power on. Voltages look good, plus 18 and minus 18, and I can hear the vector noise coming from the yoke coils. One thing that I've discovered looking at the various schematic revisions of this monitor is that they added some components on the newer revision DAC circuits. On the left, we see the old revision where pin 15 and 18 of the DAC IC are connected together. On the right, we have the newer revision where an 820 ohms resistor has been added between pins 15 and 18, probably as a current limit. Then a protection diode has been added on the analog switch IC. So I applied the upgrades on both the monitor PCBs and servicing, starting by cutting the trace that connects pin 15 and 18 of both DAC ICs. Then I've added the 820 ohms resistors directly under the PCB. And similarly, the protection diode has been added under the switch IC. One thing I noticed soon with this PCB was a hissing sound and the smell of ozone, so I've started observing the PCB in the dark. And sure enough, I identified a small corona discharge coming from the high voltage tripler assembly. This is probably the point that generates that high voltage discharge. In fact, after cleaning the area with alcohol, it seems this is a wire that has been cut. Probably it was a lower high voltage tap exiting from this multiplier assembly. The tripler assembly on the other monitor seems not having that additional wire anyway. So I completely covered the exposed wire with 2-component epoxy and let it cure for 24 hours. This eliminated the high voltage discharge. The last PCB on this set is the audio effect generator and amplifier. The usual capacitor and junction checks have shown no evident problems, so I can just hook it up to the main logic PCB. However, on the wiring harness going to the speaker, they have added 2 series electrolytic capacitors connected with opposite polarity, and one of them has a broken pin. Now, since the speaker output comes from a symmetric drive circuit with respect to ground, there should never be any DC component on it, so the series capacitors are not really needed except if one of the final transistors blow up or one of the power supply rails fails. So I replaced the broken capacitor with a new one and left the other one that still was fine according to my LCR meter. This will save the speaker in case of any failure of the power amplifier or the power supply. Another issue I found is this connector that was missing the cable clamp, so it couldn't even be removed without the cable coming loose. Since I had to order a new connector, I've just borrowed the audio cable from another PCB set for the moment. To completely test the game, I need also to connect the control switches wiring. In this game, there's yet another small PCB. And this goes to another connector present in the logic PCB. Some wires on the switches are missing. So I've added some additional wires to restore the connection on all switches. And last, I've connected a micro switch to the coin wires to simulate a coin insertion. With all the boards connected together, the game starts fine in attract mode. However, the monitor XY deflection is not set properly, as it looks too wide. Luckily, these boards have a test screen to adjust the monitor deflection size and speed. And after a few minutes fiddling with trimmers, it looks good enough. Now, there's surely a problem with the audio, as we should hear the motor sound even in attract mode. To debug the missing audio, I'll start by checking the signals that should arrive from the logic PCB to the audio board on pins 1, 3 and 5 of IC25. Pin 1 looks floating. Also pin 3 seems unconnected. After some continuity checks with the multimeter, I've realized the audio connector was backwards. The orientation is probably marked for the other PCB set, so I've reversed one end of the cable. Now the input pins are correctly driven, but we still have no sound output. On pin 15 of IC9 we should have a high signal whenever the motor sound is activated. And yes, here it is. At this point I've started following the analog sound output on the various amplifier stages. And here we have a signal. Even here it looks good. This one seems okay too. Now to make a long story short, let's join these two wires. Here is the sound. These two wires were covered with insulating tape and they weren't making any contact. At this point I decided to connect the video output to the digital to analog converter board that I designed for the old Cinematronics vector games. The board allowed the use of a normal analog vector monitor, like in this case my little homemade 11 inches one. In this way I can have more room on the bench and testing all game functions became easier. Coin input works fine. I'm going to test all inputs to make sure everything works. Of course, I also needed to test the second player inputs. So all looks good. However, as I do with every repair, I keep the finished boards on the bench for a few days, powering them on and playing a bit once in a while to make sure the board has no hidden or random fault. This logic PCB died abruptly soon after I recorded the final game test. The LED glowing means the machine is not able to execute its code correctly. Eventually, the fix for this problem took a large amount of time and effort, so it will be covered in a future video. I hope this repair video was interesting and that you learned something. If you have any question, please use the comment section below. It's all for now. Have a nice time and thank you for watching.